Welcome back to the MOOC on Information Security. Today, we will discuss a new topic, security problems. The objectives of this session are to understand the various security issues, to understand the recent security challenges for information, to get an idea about the vulnerabilities in information security, to learn active and passive attacks happening on information. Now, let's start with the security issues. A security issue is any unmitigated risk or vulnerability in your system that hackers can use to do damage to your systems or data. In most of the cases related to computer crime or cybercrime, the cheats are normal people who observe a weakness in a security system that allows them to access cash or other valuables. Among the reasons given for the growing cost of cybercrime are quick adoption of new technologies by cyber criminals, the increased number of new users online, especially from low-income countries with weak cybersecurity, the increased ease of committing cybercrime with the growth of cybercrime as a service, an expanding number of cybercrime centers that now include Brazil, India, North Korea, and Vietnam. A growing financial sophistication among top-tier cyber criminals that, among other things, make monetization easier. According to the McAfee report, monetization of stolen data, which has always been a problem for cyber criminals, seems to have become less difficult because of improvements in cybercrime black markets and the use of digital currencies. Information security challenges. Today, information security is the main component of the country's overall national security and economic security strategies. With the increase of the cyber attacks, every organization needs a security analyst who makes sure that their system is secured. These security analysts face many challenges related to information security, such as securing confidential data of government organizations, securing the private organization servers, etc. The recent important information security challenges are described below. Ransomware evolution. Ransomware is a type of malware in which the data on a victim's computer is locked and payment is demanded before the ransom data is unlocked. After successful payment, access rights return to the victim. Ransomware is the curse of cybersecurity, data professionals, IT, and executives. Ransomware attacks are growing day by day in the areas of cybercrime. IT professionals and business leaders need to have a powerful recovery strategy against the malware attacks to protect their organization. It involves proper planning to recover corporate and customers' data and application, as well as reporting any breaches against the notifiable data breaches scheme. Blockchain revolution. Blockchain technology is the most important invention in computing era. It is the first time in human history that we have a genuinely native digital medium for peer-to-peer value exchange. The blockchain is a technology that enables cryptocurrencies like Bitcoin. The blockchain is a vast global platform that allows two or more parties to do a transaction or do business without needing a third party for establishing trust. It is difficult to predict what blockchain systems will offer in regards to cybersecurity. The professionals in cybersecurity can make some educated guesses regarding blockchain. As the application and utility of blockchain in a cybersecurity context emerges, there will be a healthy tension but also complementary integrations with traditional proven cybersecurity approaches. IoT Threats. IoT stands for Internet of Things. It is a system of interrelated physical devices which can be accessible through the Internet. The connected physical devices have a unique identifier UID and have the ability to transfer data over a network without any requirements of the human-to-human or human-to-computer interaction. The firmware and software which is running on IoT devices make consumer and businesses highly susceptible to cyber attacks. When IoT things were designed, it is not considered in mind about the used in cybersecurity and for commercial purposes. So, every organization needs to work with cybersecurity professionals to ensure the security of their password policies, session handling, user verification, multi-factor authentication, and security protocols to help in managing the risk. AI expansion. AI is the short form of artificial intelligence. According to John McCarthy, father of artificial intelligence, AI is the science and engineering of making intelligent machines, especially intelligent computer programs. It is the area of computer science in which creation of intelligent machines that does works and reacts like humans are involved. Some of the activities related to artificial intelligence include speech recognition, learning, planning, problem solving, etc. The key benefits with AI into our cybersecurity strategy has the ability to protect and defend an environment when the malicious attack begins, thus mitigation the impact. AI takes immediate action against the malicious attacks at a moment when threats impact a business. IT business leaders and cybersecurity strategy teams consider AI as a future protective control that will allow our business to stay ahead of the cybersecurity technology curve. Serverless apps vulnerability. Serverless architecture and apps is an application which depends on a third-party cloud infrastructure or on a backend service such as Google Cloud Function. Amazon Web Services Lambda, AWS Lambda, etc. are the serverless apps invite the cyber attacks to spread threats on their system easily because the user accesses the application locally or off server on their device. Therefore, it is the user responsibility for the security precautions while using serverless application. The serverless apps do nothing to keep the attackers away from our data. The serverless application doesn't help if an attack gains access to our data through vulnerabilities such as leaked credentials, a compromised insider, or by any other means than serverless. We can run software with the application which provides best chance to defeat the cyber criminals. The serverless applications are typically small in size. It helps developers to launch their applications quickly and easily. They don't need to worry about the underlying infrastructure. The web services and data processing tools are examples of the most common serverless apps. Cloud attacks. Most of us today use cloud services for personal and professional needs. Also, hacking cloud platforms to steal user data is one of the challenges in cybersecurity for business. We are all aware of the infamous iCloud hack which exposed private photos of celebrities. If such an attack is carried out on enterprise data, it could pose a massive threat to the organization and maybe even lead to the collapse. Outdated hardware. Well, don't be surprised. Not all challenges of information security come in the form of software attacks. With software developers realizing the risk of software vulnerabilities, they offer a periodic update. However, these new updates might not be compatible with the hardware of the device. This is what leads to outdated hardware, wherein the hardware isn't advanced enough to run the latest software versions. This leaves such devices on an older version of the software, making them highly susceptible to cyber attacks. Vulnerabilities in information security. Vulnerabilities are weaknesses in a system that gives threats the opportunity to compromise assets. All systems have vulnerabilities. Even though the technologies are improving, the number of vulnerabilities also is increasing, such as tens of millions of lines of code, many developers, human weaknesses, etc. Vulnerabilities happen because of hardware, software, network, and procedural issues. Hardware vulnerability. Hardware vulnerability is a weakness which can use to attack the system hardware through physically or remotely. For example, old version of systems or devices, unprotected storage, unencrypted devices, etc. Software vulnerability. A software error happens in development or configuration, such as the execution of it can violate the security policy. For example, lack of input validation, unverified uploads, cross-site scripting, or unencrypted data, etc. Network vulnerability. A weakness happens in network which can be hardware or software. For example, unprotected communication, malware or malicious software such as viruses, keyloggers, worms, etc. Social engineering attacks and misconfigured firewalls. Procedural vulnerability. A weakness happens in an organization's operational method. For example, password procedure. Password should follow the standard password policy. Training procedure. Employees must know which action should be taken and what to do to handle the security. Employees must never be asked for user credentials online. Make the employees know social engineering and phishing threats. Terminologies in information security. Theft of intellectual property means violation of intellectual property rights like copyrights, patents, etc. Identity theft. It means to ask someone else to obtain person's personal information or to access vital information they have, like accessing the computer or social media account of a person by logging into the account by using their login credentials. Theft of equipment and information is increasing these days due to the mobile nature of devices and increasing information capacity. Sabotage. It means destroying organization's website to cause loss of confidence on part of its customer. Information extortion means theft of company's property or information to receive payment in exchange. For example, ransomware may lock victim's file, making them inaccessible, thus forcing victim to make payment in exchange. Only after payment, victim's file will be unlocked. Active attacks. An active attack attempts to alter system resources or affect their operations. Active attack involves some modification of the data stream or creation of false statement. Types of active attacks are as following. Masquerade. Masquerade attack take place when one entity pretends to be different entity. A masquerade attack involves one of the other forms of active attacks. Modification of messages. It means that some portion of a message is altered or that message is delayed or reordered to produce an unauthorized effect. For example, a message meaning allow John to read confidential file X is modified as allow Smith to read confidential file X. Repudiation. This attack is done by either sender or receiver. The sender or receiver can deny later that he or she has sent or received a message. For example, customer asks his bank to transfer an amount to someone, and later on the sender or customer denied that he had made such a request. This is repudiation. Replay. It involves the passive capture of a message and its subsequent the transmission to produce an authorized effect. Denial of service. It prevents normal use of communication facilities. This attack may have a specific target. For example, an entity may suppress all messages directed to a particular destination. Another form of service denial is the disruption of an entire network either by disabling the network or by overloading it by messages so as to degrade performance. Protective measures against active attacks. Unlike a passive attack, an active attack is more likely to be discovered quickly by the target upon executing it. The following are some protective measures against this type of attack. A random session key can be generated which is only valid for one transaction at a time. This should effectively prevent a malicious user from retransmitting the original message after the original session ends. Using one-time passwords help to authenticate transactions and sessions between communicating parties. This guarantees that even though an attacker was successful in recording and retransmitting the captured message again, the associated password will expire by then. Using Kerberos authentication protocol, usually used in Microsoft Windows Active Directory, which supports many countermeasures against different types of replay attacks. Passive attacks. A passive attack attempts to learn or make use of information from the system but does not affect system resources. Passive attacks are in the nature of eavesdropping on or monitoring of transmission. The goal of the opponent is to obtain information is being transmitted. Types of passive attacks are as follows. The release of message content. Telephonic conversation, an electronic mail message or a transferred file may contain sensitive or confidential information. We would like to prevent an opponent from learning the contents of these transmissions. Traffic analysis. Suppose that we had a way of masking or encryption of information so that the attacker, even if captured the message, could not extract any information from the message. The opponent could determine the location and identity of communicating host and could observe the frequency and length of messages being exchanged. This information might be useful in guessing the nature of the communication that was taking place. Protective measures against passive attacks. Detecting a passive attack is very difficult and impossible in many cases because it does not involve data alteration in any way. However, you can implement protective measures to stop it, including using encryption techniques to scramble messages, making them unreadable for any unintended recipients. Two types of encryptions can be implemented in this case. Symmetric keys, same key on both ends, or we still have the problem in exchanging the secret key secretly. Public key encryption, where each party, whether it is a user, program or system involved in the communication, has two keys, one public and one private, that must be kept secret. An example of this type is using SSL or TLS certificates, HTTPS, that are used to ensure the validity of machine identities between a web server and someone's browser. Avoid posting sensitive information publicly. Example, private and company information that can be used by outside hackers to invade your private network. Security measures to be taken for the security. To protect the system, security measures can be taken at the following levels. Physical. The sites containing computer systems must be physically secured against armed and malicious intruders. The workstations must be carefully protected. Human. Only appropriate users must have the authorization to access the system. Phishing or collecting confidential information and dumpster diving, collecting basic information so as to gain unauthorized access, must be avoided. Operating system. The system must protect itself from accidental or purposeful security breaches. Networking system. Almost all of the information is shared between different systems via a network. Intercepting these data could be just as harmful as breaking into a computer. Henceforth, networks should be properly secured against such attacks. So, in this session, we have discussed different threats possible and the properties of active and passive attacks. Hope this session was useful. See you next time. Bye.